Hi everyone, this is a MATH082 video. We are in Chapter 4 and we are learning methods of factoring. So the specific method I'm about to teach you is not in the MATH082 textbook. It's in the MATH083 textbook at CCBC. This textbook is available at ccbcmd.edu. If you go to the math website simply by using the CCBC search engine to search for mathematics, okay, on the home page there is a link to the MATH083 textbook. So if you want to read through the book, see more examples, and do problems and check your answers, you can do that there. So let's go over the general factoring strategy we've been using for Chapter 4. So remember, the very first thing we always do is we look for our GCF. After we do that, we ask ourselves, how many terms do we have? Okay, and then remember in section 4.2, we learned that if we have 4 terms, then we use factoring by grouping. And then, in my previous videos as well, we learned that if we have 3 terms, we can use the AC method. Okay, so if you want to think about it, this is really kind of an extension of 4.3. We're going to continue learning how to use the AC method, only this time we are going to be working with values of A, where the leading coefficient is larger than 1. So let's get started. Here's our first example. So you can see here, by the way, when I talk about A, B, and C, I'm assuming that it's in this form. So in this case, A is 3, B is 11, and C is 6. So let's fill in our table down here. Okay, so we have identified A, B, and C. Now we need to find the product of A and C. So in this problem, A is 3, C is 6, and 3 times 6 is 18. So AC is 18, and as you can see, B is 11. So what we need to do is we need to go through and start listing the factors of 18. So there are lots of options. We could think of 3 times 6. What else? We could have 2 times 9. Okay, and there's probably other options too, especially when you consider the possibilities of negative numbers. So let's see. 3 times 6 is 18. 3 plus 6 is 9. So that option is not going to work. So let's look at our next option. We have 2 times 9 is 18. And 2 plus 9 is 11, which, luckily enough, is exactly what we want. So, in our previous videos, we had a shortcut where we wrote something like this, and then we just filled in x plus 2 and x plus 9. Now, notice, there is a 3x here, okay? Let's just double check. Let's expand this. Let's distribute this and prove to ourselves that this, in fact, is not the solution, okay? Because if I FOIL this, I have x squared plus 2x plus 9x plus 18. That gives me x squared plus 11x plus 18, and hopefully you can see this thing is not the same as this thing. So that shortcut that we had before of writing out the factors doesn't work when A is larger than 1. We cannot do this. So we have to use that grouping method that I showed you last time in the last videos. So we have 3x squared plus 11x plus 6. So I'm going to rewrite this 11x as the sum of 2x plus 9x. So hopefully you can see that this line right here is equivalent to the second line right here. And then we have 4 terms. What do we do with 4 terms? Well, we tend to group them and then factor out the GCF. So if you need practice on factoring by grouping, please go back and watch those videos that I've already posted, and they can help you. Uh-oh, I think I messed up. Okay, so we did our factoring by grouping. So we have this right here and this right here. Those are the same. So we can factor out the 3x plus 2. And what's left is x plus 3. Okay, and remember, you can always check these and verify. And how do we check them? We check by foiling. So 3x times x is 3x squared. That's f for first, right? And then we have our outer terms. That's o. That's 3x times 3, or 9x. Then we have our inner terms. That's 2 times x. And then we have our outer terms, 2 times 3, which is, I'm sorry, our last terms. I said the wrong word. 2 times 3, which is 6. And if you go through and combine like terms, you see that we end up with exactly what we started with up here. All right, let's do one more example. So this time we have 10x squared minus 27x plus 5. So again, the first thing we have to do, remember when we factor, is we always look for our GCF. In this case, our GCF is 1, so now we can proceed to using the AC method since we have 3 terms. All right, so our A is 10, our B is negative 27, and our C is positive 5. So AC is going to be 50, and B is negative 27. Now you might realize at this point that we have a lot of different options of factors of 50. We have 5 and 10, we have 2 and 25, we have 1 and 50. We have a lot. But one thing we want to be aware of is that when I add these numbers together, they are going to be negative. So I don't want to list, for example, 10 times 5, because I know that 10 plus 5 is going to give me a positive number, positive 15. So instead of listing positive terms, instead I want to be listing negative terms, like negative 10 times negative 5, which would give me a negative 15. Now, of course, neither of these answers is equal to negative 27, so neither one of them works. But again, I still want to be thinking about negative numbers because the sum of two numbers has to be negative according to what B is right here. All right, so let's try negative 25 times negative 2. Again, that would still work to give us a positive 50. And luckily for us, it turns out that when we add them together, we get negative 27. So that's our answer. All right, so let's see if we can keep going. So again, remember, we cannot write out our solution like this. This is not going to work. Okay, and if you don't believe me, you can FOIL these things and prove to yourself that what you get when you FOIL them is not what we started with. As long as your A, the coefficient of x squared, is larger than 1, then you have to take this extra step and group things. Okay, so we are going to rewrite negative 27 as minus 25x minus 2x. All right, so then we want to use factoring by grouping, but you might notice this middle sign here is negative, so we have to join these guys with a positive number here. Don't want that yet. Okay, and then having done that, then I can group the first two terms together and the second two terms together. So I can factor a 5x out here, and I can factor out, doesn't look like I can really factor anything out, but I'm actually, because I want a 2x minus 5 here, and right now I have a negative 2x plus 5, you can see those are not the same. So what I'm going to do, I'm going to do a little trick here. I'm going to factor out a negative 1. Factoring out a negative 1 gives me a positive 2x here, and then it gives me a negative 5 here. And if you're unclear, go ahead and do the distributive property real quick to prove to yourself that negative 1 times 2x gives you negative 2x, and negative 1 times negative 5 gives you positive 5. Okay, so now we have our goal, which is that we have 2x minus 5 in both places. So that means we can factor that guy out. And then we have 5x minus 1, or 5x plus negative 1, and that's our final answer.